So let's continue our exploration of quadric surfaces. Here we got the equation y equals x squared plus z squared. When we have something like this, it helps to look, since x and z are squared, maybe affecting y. Let's see what happens with y. If we turn y into a constant, well, if it's a negative, we've got a negative equals the sum of two positive values. That's going to generate complex numbers if we tried to solve for x or z. And when we want to look at real graphs, that's not going to work. So our constant's got to be 0 or greater. So that's what I said. Let's say y equals c is greater than or equal to 0. We get circles. If we say y equals 1, we get x squared plus z squared equals 1. That's like the unit circle, but in the xz plane, which goes into the paper. If we say y equals 4, we get x squared plus z squared equals 4, which is a circle of radius 2 going into the paper. So if I go to graph that, I got my y-axis, my z-axis, my x-axis. Going into the paper makes the circle look a little squishy sideways. That's to represent looking at the paper at an angle. There's my radius 1 circle, my radius 2 circle. Clearly, as we go to the right, these circles are getting bigger and bigger and bigger. As we go to the left, they're getting smaller and smaller and smaller. And so, like, what happens when y equals 0? Do we get like a point? Like a actual cone? Or do we get something curved, like a parabola? So let's take a look at that. Let's actually look at what happens when y equals 0. If I plug in y equals 0 and then just pick another equation to equal 0, or another variable to equal 0, like x. If x equals 0, I'm left with y equals z squared, which is the blue line we see here. And that's definitely parabolic. So we've got something that makes this parabola-like shape going like that. And maybe if I put dots in the back, I could do a dotted line showing something like that. So we got a parabola cone looking thing. This is called a circular paraboloid. It's got a curved end. What if we had y squared instead of y? Let's take a look at that. So we've got a similar setup. Now we've got y squared equals x squared plus z squared. And I could do the same thing, making these constants. And let's take a look at what happens. When we do y equals 0 and x equals 0, we get y squared equals z squared. So y equals plus or minus z. These are making two lines that cross, and they're going to cross in a point. So this is going to be a pointy value. And you'll notice what happens to the shapes of the circles. Let me rewrite the equation where we can see it here, since I've got that camera zoomed in. If I plugged in y equals 4 like I did on the last one, I'm going to get x squared plus z squared equals 16 is a circle of radius 4 rather than radius 2. So like the y distance here, whatever I plug in, is kind of like I'm making a circle that way, and this distance from along the y-axis is also the distance up, or the distance in the x. These lengths are all y. But what that ends up doing is it makes it so we make a straight line. And now I don't have a paraboloid that's getting wider. I just have flat out a snow cone. Pointy tip. But the y squared makes it so if I plug in a negative y, the equation still works. So we got to do it along the other side as well. So what we've got is two snow cones point to point touching each other and opening up to the right. These are called circular cones. Now, the names of what, I'm not testing you on what these names are. Hopefully the names kind of make sense. Circular cone, this is making a snow cone kind of effect. The circular paraboloid, it was a paraboloid. We saw parabola, we saw circles. So the name circular paraboloid kind of indicates what's going on there. Just keep in mind, that's what we're going with. I'm not going to test you on names, stuff like that. I might have you graph one of these for the test, still undecided. Let's stop this. Let's give you something else to think about. What if we had the coefficient of x squared or y squared was different? We had y equals x squared plus z squared. What if we threw in an a or a b? Well, now those circles aren't going to be circular anymore. They're going to be ellipses. So we'll have like elliptical cones if we do y squared. Or we'll have like these elliptical or circular or elliptical paraboloids. But we'll do that in class. I recommend having you try this out on your own. So like, give it a try. Try graphing x equals y squared over 16 plus z squared over 4. Then maybe look at trying z squared equals x squared plus y squared. Maybe we can, I don't know, should we add a value to it? Let's make this over 9. Let's make it fun. Okay. And that'll be it for this video.